What's going on, everyone, and welcome to episode 175 of the Junkies Podcast. Today I'm chatting with Rob Tessier, who's the National Director of Advanced Fabrication and International Senior Expert at Airgas Air Liquide. Rob is a wealth of knowledge when it comes to welding, equipment setup, troubleshooting, automation, welding efficiency, and process improvement. He's another one of the people that I hold in high regard and consider to be a source of personal inspiration for me along my welding journey. I'm sure y'all are going to thoroughly enjoy this episode and learn some great information. Before we get into the episode, I want to take a moment to recognize our holiday yesterday. I typically release an episode every Monday. However, yesterday was Memorial Day and a very important day for me. Memorial Day is a day of remembrance for all of our military men and women who have made the ultimate sacrifice so that we can continue to enjoy all of our rights we hold so dear. Regardless of your political thoughts, feelings, and positions, never forget that had it not been for their sacrifice of these brave men and women, the America we love would look drastically different today. So don't let their sacrifice be in vain. Do your best to be a good American. Treat one another with kindness. Love and respect your country. Exercise the rights they fought and died for. And take time to remember them. Today's episode of the Junkies Podcast is brought to you by Rockmount Research and Alloys. If you're not familiar with this company yet, go check out episode 149 of the Junkies Podcast, where I talk to Pat Adams about these great maintenance welding electrodes. Rockmount makes the rods you need to get out of a bind. When your equipment breaks, your first instinct is to grab some 7018 or maybe some 70S6 to weld up whatever's cracked or broken. But those rods were made for initial fabrication in a controlled environment. But once those pieces of equipment get out in the field, they're covered with paint, sand, oil, grease, and God knows what else. These rods are no longer effective. What you need to get is some Brutus rods, which can be used on a multitude of different steels, even with the similar steels. Brutus also boasts 125,000 pounds of tensile strength and gives you up to 35% elongation, helping you make a repair that's going to last. Stop putting band-aids on your equipment and fix it right the first time with Rockmount Research and Alloys. They make rods to weld stronger and last longer. Check them out today at rockmountwelding.com, and when you place an order, tell them the Art Junkie sent you. We're also brought to you by Fronius USA. For the month of June, they have a great deal for listeners of the Junkies Podcast. Right now, when you buy any TransSteel 2200 compact welding machine, you get a free rolling tool case to go along with it. All you have to do is go to shopweldingsupplies.com/ArcJunkies. It's a $300 value. Just head over to the website, put the machine and the tool case in your cart, and use Arc Junkies in the discount box at checkout. It's that easy. Now you can take your machine on the go for all of your portable welding needs. The TransSteel 2200 is a compact 3-in-1 solution. It's the first single-phase inverter power source from Fronius that's also multi-process capable, bringing together stick, MIG, and TIG in a single device. The TransSteel 2200 is characterized by the intelligent design of the device, ease of use, robustness, and high level of reliability. Weighing in at just 34.2 pounds, it's one of the lightest multi-process machines on the market. It's highly portable, and you can run it up to 300 foot of extension cords without a loss of power. You also have the ability to MIG weld aluminum without the need for a spool gun, and you can run 1-pound spools or 11-pound spools without the need for an adapter. Head on over to shopweldingsupplies.com/ArcJunkies and get yours today. We're also brought to you by Everlast Welders. I get it. You want to get into welding, or you want to start your side business, but you don't have a ton of money to invest in equipment right now? No problem. Head on over to everlastwelders.com and pick up a multi-process machine for your home shop or small business today and save hundreds without sacrificing performance, functions, or features. You never know what process you're going to need for that next project going through the door, so check out the MTS 255 or 275 today and get access to all the processes you need for a fraction of the price. I'm talking MIG, stick, TIG, both DC for steel and stainless, and AC for all of your aluminum. It's compatible with a spool gun as well. And when you buy any machine that comes with a stock foot pedal, you can use Arc Junkies in the comments section to check out and get a free Nova foot pedal and TIG torch upgrade. It's a $100 value. So stop by everlastwelders.com and check out their full line of equipment today. They have a machine for every project and every budget. All right, y'all know what time it is. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies Podcast. Helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, ladies and gentlemen, joining me today is Rob Tessier, the National Director of Advanced Fabrication and International Senior Expert at Airgas and Air Liquide Company, coming to us out of Texas today. Rob, how you doing?
Not bad, Jason. How you doing, man?
I'm doing pretty good. So why did you decide welding? Before that, backstory, I met you when I worked over at weld.com, and you and Bill Farmer and Man Cub and I would sit around and we would listen to you guys talk back and forth for hours, and it just blew our minds. You're probably, between you two, probably the smartest people I've ever met when it comes to like the science behind welding. You know, like understanding the actual characteristics, what gas does, what wire speed does, what voltage does, all these different characteristics that we kind of dial in a machine and we go to work. You guys understand and just kind of wax poetic about all these different, functions when it comes to machines and the different settings that we have to go through and deal with on a daily basis. And I started understanding at that point, this stuff's even more important than I thought, because a lot of the things that I would overlook and say, no, this right here, your voltage and your wire feed speed, that's very important. But I mean, you guys got down to like the minute details, and I was like, holy shit. And I've said it before, I'll say it again. The more I learn about welding, the more I understand that I don't know anything about welding.
Well, get ready for this. The more I learn about welding, the less I realize I know about welding, and it doesn't stop. I tend to think that welding is kind of like walking into the ocean. You keep on walking for a little while, and you're past your ankles, now you're at your knees and all that sort of thing, and all of a sudden you're up to your waist, and you've been in it for a long time, and you're like, yeah, I'm pretty good, and all of a sudden you take that next step, and that next step, you kind of like hit that ridge, and you drop in, and you're over your head. And that constantly happens. And if it's not happening, you're not investing in yourself and you're not pushing yourself. I'll promise you, anyone that feels that they know everything about welding is wrong. You can't. Mm-hmm. You just can't know everything, but you got to love this. And if you love this business, well, you're going to want to know. You're going to ask the question, and you're going to listen to somebody. And that doesn't mean that you're going to get it from an old timer. It doesn't mean that you're going to get information from everybody you talk to. And you just got to use that information and kind of like put it into your jigsaw puzzle. I look at welding and I look at applications kind of like a huge jigsaw puzzle. Think about it this way. You have a jigsaw puzzle and you're starting to put your pieces together, and you've got the same puzzle, I've got the same puzzle, and all that sort of thing, and we're putting different parts in different places. Well, I don't know what parts you're missing, and you don't know what parts I'm missing. So, if you ask questions, and that's what I'm saying, if you invest in yourself and you're asking questions and you're listening to people, all of a sudden it's just like, oh, that's where that piece goes. And you put that in, and now that bridges a gap, and it helps you start building out your jigsaw puzzle. And education, truthfully, is that big jigsaw puzzle. It's just like, you got to know more. And the more you know, the more you realize, the bigger the puzzle is. And that's what makes this fun. Makes it a blast.
So how did you get into welding? I mean, where was your start?
I was in the United States Air Force, and I was in the Air Force a long, long time ago. And for all practical purposes, it was something that I learned how to do in the Air Force. It was part of my job. And I had several of the things that I had to do, but I picked it up and I loved it. It was like second nature. I just loved welding, and it wasn't everything I had to do, but for all practical purposes, it was a decent portion of the job that I had. Well, got out of the Air Force, went to work for Chrysler for a period of time, and was doing a little bit of welding there. More than not, though, it was really working on wrecked vehicles, because I happen to love cars, and did some body work for them, and truthfully, that was a lot of fun. Left that, and it's just like started my own company for a period of time, and made some decent money, sold that out. But I always kind of like wanted to get back into welding. So I basically got back into welding, and, it just kind of like grows from there. I just said it a little bit earlier. I mean, it's just like it all comes down to investing in yourself and really just always asking that question. So that's fundamentally what I was doing. It's just like, well, what about this? And what about that? And if you invest if you invest yourself and you invest your time into learning about welding, and you spend maybe an hour a day, you're going to find out that you're going to learn an awful lot. Then the more you do that, the more you learn. That's kind of like how it started. And then, of course, then you start jumping into formal education and gosh, it kind of like really fast tracks it. And then, you wake up and it's just like, this is probably the best job that you could possibly have in the world. And it's just a matter of how do you dig in? And it's just started off as something that I had to do that I just like doing, and I can't get away from it. I love it.
It's a pretty in-depth rabbit hole. I mean, when you think about it, like the more you start digging into it, the deeper it gets. And you've got a really cool job because you do a lot of like process efficiencies. Like, how can we make this process more efficient? How can we, take that deposition rate and get the most out of that wire for the amount of money that we're going to spend? And what type of gas composition is going to give us the best performance for the money that we're going to spend? So you do a lot as far as, I guess, a field agent for, the certified welding supervisor. I mean, you take that stuff to a whole nother level.
Well, it's, and I believe, I mean, I have a lot of brothers and sisters out there, and it's just like we're CWIs, we're CWEs, we're CWSs, and that's, that certified welding supervisor class is really good. But, there were some openings in it that really weren't being addressed. And so, it's just like, you got to kind of like look at, all right, what else can you do to kind of like round this thing out? And when you look at efficiencies are absolutely critical going ahead and address. I mean, I got a couple patents on some processes that are used. And as you look at it, it's just like people really come down to this point to whereas it's just like when you walk into a shop, it's always about the welder and, the welder didn't do this and the welder didn't do that, but that's not necessarily the truth. As a matter of fact, very seldom is it the welder's fault that something's going on or something's not right. If you think about it, it's the system itself. If the system's failed or if the system's flawed, the welder is basically, fighting for survival. People have this pride of ownership or I don't know many people that go to work that aren't proud. I mean, they're just proud of what they're doing, what they're building, whether they're in construction, whether they're building cars or whether they're building tankers or, pressure vessels, regardless, or if they're in the shipbuilding industry, they're proud of what they do. They're proud of the product that they're that they're building. They don't show up to work to go ahead and really deliver a poor workmanship or anything of that nature. What they're really doing is like they're showing up and they want to do it right. Here's the issue, that if your efficiencies within your system aren't correct, it can make a really good welder look bad. So again, let me ask you a quick question. Where does spatter come from? Where does welding spatter come from? How does that happen?
Piss poor wire settings.
Really, is it?
Well, I mean, there could be a lot of things. I'm gonna pull a card from Chandler Vincent's playbook, and he talked about current carrying capacity. So I guess anywhere in your system where you have resistance built up could cause issues, because I've seen a lot of machines out there, some of them brand new right out of the box. I mean, hell, you and I tested a few one day, and wire feed speed was not actually what was being put out on the display. So I mean, if that's what you rely on, is that either that analog dial or your digital dial there on your welding machine, it says I'm supposed to be hitting 350 inches a minute, and you pull the trigger on it and you count it off, and you're only getting 24 inches a minute or 240 inches a minute, you've got a difference there. So I would say it's anywhere where you can lose resistance, because you might have your machine dialed in exactly to that WPS, but there's some different things at play. It's not always what's written on the readout is what you're getting at the puddle.
Well, you're absolutely correct. You see, I'm glad you brought that up, and you bring up resistance, and resistance is exactly it. Let me ask you a better question real quick. How many pounds of wire go through a contact tip? In a semi-automatic, I've got everyday guy, on a welding torch and all that kind of stuff. He's pulling the trigger. How many pounds of wire go through a contact tip before he pins that tip? Average guy.
Average, okay, I'm glad we're not saying students, because I've seen them get get a quarter pound out before they clog it up. I would hope it's somewhere close to 33, like one tip per spool.
Really? Yeah, that would be great. And truthfully, that's close to best in class. Now, that doesn't mean that theoretically it couldn't last a lot longer, but we don't live in a theoretical world, do we?
No.
As a matter of fact, we live in an actual world, and for all practical purposes, an average person is going to put about 14 pounds of wire through a contact tip, going to pin the tip. Now you want to know why. Here we are, we're talking about, well, yeah, hey, you ought to be able to get 33, and there's some people that do. There's some people that get 33, 35, up to 40 pounds of wire through one contact tip. Yet, there are people buying the exact same MIG gun, the exact same contact tip, and they're only getting 7. What's the difference? You already said it once.
Current carrying capacity? Yeah.
Well, it's resistance. It's electrical resistance. You see, a contact tip is, all that basically is an indicator. It's showing you what's going on. Well, if wire welding is an electrical process, and we're electrically charging that wire at the contact tip, and right after the contact tip, we basically move right into a transfer mode. Isn't that correct?
Mm-hmm.
All right. Well, if in fact something is wrong in your electrical system, where do you think it's going to show up first, or where do you think it's going to show up at all? It's going to show up in that transfer. And again, if you look at that wire machine, or you look at your welding machine, and let's say I'm telling you to run an 045 wire with, let's say, a 10% CO2 gas, remainder argon, and I'm going to tell you to run about 400 inches a minute of wire feed speed, and I'm going to ask you to run about 28 and a half volts. If everything's right, you should be running about 310 amps, give or take, depending on contact tip to work distance. I mean, that's really where you're going to be. You're going to be right around there. But you see, if let's say when I wrote that procedure, I had a machine that had probably 10-foot long cables. I had a massive ground clamp or work clamp, and that was made out of copper, tied to the table. Everything was really sound. Now I got on the shop floor, and I'm out on the shop floor, and I've got 25, 50-foot runs on cable. Those cables are old. They've been run over by forklifts. You've seen the lugs on this thing, and there's like frayed wire that's coming out of all the lugs. And let's just say we have a steel ground clamp, kind of like, because that's cheap. I mean, they cost a lot less.
Yeah.
Right? So I mean, it's just like
pretty much what the employer's
steel conducts electricity better than copper, right? Well, no, that's not true. So but we got this steel clamp and all that sort of thing because somebody paid $7 for it rather than paying $12 or $15 for something that's good. And now this welder, this person is there trying to weld with this thing, and they light it up. All right, well, I got 28 and a half volts dialed in at my machine, and at the arc, I've got 23 and a half, 24 volts. Well, all of a sudden, what's that wire doing? I mean, it's bouncing all over the place. If I can establish a decent or a reasonable arc, I'm going to have spatter. I'm going to have all kinds of a mess here. Well, where's all that stuff going? It's going back up into my nozzle. It's going to hit my tip, and I'm going to pin a tip. Yeah, all right. Is it the contact tip? No. Is it the welder? No. Is it bad gas? No. Might be. Might be something else going on there too. But the crazy part is that I didn't get 33 pounds of wire through that contact tip. So I'm going to take that contact tip out. I'm going to run some wire out. I'm going to snip it. I'm going to put in another contact tip, but I'm going to hand tighten it this time. You know why? Because, well, heck, man, I'm going to go through so many contact tips. I'm tired. I'm just tired of having to go on ahead. And I mean, it's a lot easier if it's hand tight. So now instead of getting 7 or 8 pounds of wire through it, now I'm only getting about 5 pounds of wire through it. And again, what's going on? I'm creating more resistance. if you want to lose voltage and you want to lose energy, any place where we have resistance in an electrical circuit, you start to lose that energy. Well, that's going to directly react to what's going on with that wire and what's going on. So, if I want to talk about efficiencies, I want to talk about the system. We have people that are on the floor today and they're in survival mode. You can't see electrical resistance. You can't see any of this stuff. Yet they're dealing with it, and they've got this pride of ownership. They want to do a good job. But the guy on the floor is thinking to himself, our quality guys don't know anything about welding. They couldn't write a welding procedure if their life depended on it. And then they're thinking to themselves, engineers don't really have a clue about what's going on because, if I finally get this machine dialed in, and what they'll usually do when they get that voltage drop, they'll go and they'll peel back that wire a bit. So now instead of running 410 inches a minute, now they're down to like about 325, 340 inches a minute. Well, I'm no longer running 300, 310 amps. Now I'm getting about 230, 240 amps and all that kind of happy stuff. And if I'm welding on 3/8 inch material, guess what happens? I'm not hitting the root of that weld if I'm running a fillet weld. So I put in that 5/16 weld that the engineer said that I needed. And guess what? It doesn't hold. It's breaking and all that sort of thing. So I put in a larger weld. So it'll hold, so I can get more leg strength and all that sort of thing. But ultimately, all they're trying to do is compensate for the fact that they've never hit the root of that weld. And again, they're in survival mode. We're not writing procedures, and most people are not really understanding that. It's just like, what's going on with all that resistance has to do with the fact that they're looking at a machine that says 28 volts or 28.5 volts. They're just not getting what they thought they were supposed to get. And a lot of it has to do with electrical resistance. And where's your indicator? It's that little contact tip. That contact tip will tell you more about what's going on in that welding circuit than most other people will actually realize. So there are a lot of KPIs or a lot of things that you can look at that'll carry you there. You've got to start looking at what's going on, why is it happening, and what's it causing? Because, we'll have porosity, we'll have spatter. I mean, it's like, you might have you have all these other things that are going on. And it's just like, it's always the welder. What did you do? What did you change? I don't know. I don't know what happened like that. It just happened. And they're getting beat up. We don't need to beat up our welders. We need to figure out what's wrong with our system. And that's some of the things that are going on with efficiencies. It's kind of wild, man. We're beating up the wrong people.
Yeah. That's like my favorite go-to, like when you're talking to welders, are like, well, what's wrong with this? I don't know. The machine's a piece of shit. Is it?
Yeah.
Or, is there something wrong? Is there something we can go through and fix? What are the indicators? What can we use to troubleshoot and find out exactly what's causing the issue? Because at the end of the day, the machine should be able to perform. If it's running and it's on and it's feeding wire and everything, it should be able to perform that weld. So there's obviously something's throwing it off. There's a kink in the system somewhere. We got to find it. And that's kind of what, when I talk to my students, we go through. And thanks to my buddy Nate Bowman, the weld scientist, he got me hooked up. Well, he posted a picture of a FLIR multimeter. And so I was like, man, I don't know why I would need infrared on a multimeter. And then he started showing me some applications to use. So I was like, oh shit, I gotta get one of these. This is like one of the coolest toys on the block. I gotta get one. But so now I've got an infrared multimeter. But because of the stuff that you taught me over at weld.com, how to operate that multimeter effectively and check voltage drop and make sure I'm getting the correct amperage, and then also having that thermal imaging, I can now walk through my welding shop and say, and just start scanning the booths as I'm walking by and say, okay, this guy right here's got a loose terminal. This guy's ground clamp right here is loose at the end, or, there's some wires missing out of the end of it because his ground clamp's red hot. So I can see all this because along with resistance, that's where that amperage is going, and amperage, as most people know, is heat. So anywhere that I have heat outside of that electrical system other than my puddle, I've got resistance built up somewhere. There's a loose connection, or like you said, somebody ran over the leads with a forklift. Something's going on in that system. Now I've got something to go on. I can stop the student from what they're doing and say, hey, look right here. I got a picture of this. This is your ground clamp. Let's go ahead. Let's fix this. Did you notice that it was heating up? Yeah. Well, did you notice your machine wasn't welding as good as it did yesterday? Oh, yeah. Wasn't sure what it was. I thought it was me, because I was welding good yesterday, and today I'm welding like shit. I thought, maybe lack of sleep, whatever.
I'll tell you, that trick, and truthfully, if you're going to repair your equipment, you get old static equipment and your rectifier, it's just like, if it seems like it's single phasing or something of that nature, just look at, after you fire up the machine, look at the heat coming out of each one of those diodes, and you're going to figure out which one's cold and which one's hot. All that sort of thing. It's going to tell you what's working and what's not working. Kind of crazy, but we used to diagnose stuff that way a long time ago. You bring up Nate. I know Nate. In fact, Nate used to work for us a long time ago. Well, several years ago. Went through multiple, several of my classes. He's a good dude, man. It's just like been around the block. I'm glad to see that he's doing real well. He is a knowledgeable guy, and he knows what's going on. And he's bringing. Basically, he's bringing what's going on in the welding. Basically in the welding arena, and people are listening to him. And I'm really glad that he's got the platform that he's building, because he's getting the information out. And I've read some of the stuff that he's putting out there, and for all practical purposes, he's right. You got to listen to people, and he's getting the information out. You got to give him, got to give him credit for everything that he's doing. It's pretty good, man.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Strong Hand Tools. They have all the fabrication tools you need to increase speed and accuracy. We all know that time is money, right? The more efficient you are, the faster you become, the more money you can make. Check out stronghandtools.com/ArcJunkies and see what tools they have to help you increase your speed and accuracy today. We're also brought to you by AHP Welders, and right now you can pre-order an all-new AHP Alpha TIG 225XI for only $750 and get into TIG welding with AC and DC capabilities. The 225XI delivers pro-level features in an economically minded package that outperforms other machines in the same price point. Check out ahpwelds.com and get yours pre-ordered today. Orders are going to start shipping out on June 4th. All right, let's get back into the show. Yeah, and it blows my mind, like you were saying, everybody wants to blame the welder, or, I had the same thing, when I was out in the field. It's like, oh, the engineer doesn't know what the hell he's talking about. This is too many volts, or, it's not enough voltage. And it's the same thing. And like, once you put the weld in, you're like, yeah, that's a damn good weld. Well, until you cut it into a macro etch, or you hit it with an X-ray, you're not going to see that you never punched into the root. You've got a void there. You've got a gap, and you have no idea that it's there, because now it's covered up. You got nice, even equal leg lengths, and you got a nice slick bead and everything, but there's no root in there. You never punched in. You didn't join the metal where it was most important.
It's kind of crazy in a lesser thing. And truthfully, that leads us right down this path to who's selecting what you're doing and why are you selecting it. You see, there are a lot of things that are happening there. It's just like, well, we've always done it this way, and you hear that a whole bunch.
Yeah.
It's just like, but why are you using the diameter wire that you're using? Or why are you using the gas that you're using? Why are you doing any of the things that you're using? And it's just like, well, that's what we always use. All right, well, what are your expectations? And truthfully, why are you making these particular selections? And not everybody is really kind of like in tune to what's going on in welding and why they're doing what they're doing. And I get it. It's just like, if you happen to be, the engineer of record, this is what we've got. This is the equipment we've got. These are the people that we have. So these are the modes of transfer that I know that we can do. This is how we usually handle business. And they're trying to adhere to their current welding procedures. And this isn't a matter of buying new equipment or anything of that nature, but you really got to kind of like expand your brain just a little bit. Just let's get an idea of what else is out there that I can do with what I've got.
Yeah.
Now, there's one other thing I want to bring up here real quickly. And I work for probably the largest gas company in the world. I also, it's just like, it's a sales organization. Of course, I'm kind of like on the engineering side of things, but with all that being said, it's just like when you start looking at electrical resistance, there's a game that's being played, and I hate to see it, and everybody's guilty of it. You'll have people that are looking for equipment, and they'll put out a quote, and they'll put out a bid for equipment, and they're saying, hey, look, doesn't matter if it's a Power Wave from Lincoln, or if it's a Delta Weld or whatever from Miller. It doesn't really matter who the manufacturer is. Now all of a sudden it's just like, all right, so I need 50-foot leads on this thing. I need this. And all right, so the blue box or the red box or the yellow box, they're all the same. I mean, it doesn't matter who's going to sell it to you. That box is the same. So how can somebody come up with a 10% or 15% difference in pricing? And everybody's got this idea that, well, the big companies, they have, their cost structure is so much better. It's not necessarily true. There's a couple points difference, but it's not these huge differences. Now you start looking at how you're going to spec out a machine. And this is a cautionary tale to people that are out there looking at equipment. And if you want to avoid some issues like that, you pay attention to this. Like that, when you spec something out, understand how far that, what kind of stretch do I have for cable? What size cable should it be? What size ground clamp or what size work clamp should I be getting? Specify it. If you need 2-aught cable, get 2-aught cable, because I'm going to tell you, copper costs quite a bit. And when you get a brand new machine, hey, the cable looks good. And eyeballing something like that, 2-aught cable and let's just say number 1 cable, to the naked eye, you don't really know if that's good or bad. It's brand new cable. It's nice and shiny. Everything's great.
Yeah, it looks good. It should run right.
If I'm using number 1 cable instead of 2-aught cable, that's that electrical resistance that I'm talking about. But it's a brand new machine. So somebody's going to point at the red box, the blue box, the yellow box, and they're going to say, this thing is a piece of junk. Just like you said, this machine isn't worth a damn. I got a steel ground clamp that, and we know right now, steel does not conduct electricity as well as copper does, or as well as brass does. So we're building in resistance, but it's like that's a $7 ground clamp instead of a $24 ground clamp. And somebody's looking at this thing and it's just like, well, yeah, this is significantly less expensive. I'm going to buy X. If you're going to spec out a piece of equipment, understand what you need. Understand what size cable you really have to have for the process that you're doing. If you're running 350 amps or you're running, regularly, 375 amps or 250 amps, and you know what size your cable or how long your runs are going to be on your cable, make sure you get the right cable. Make sure you get the right size, because just because it's brand new doesn't mean that it has the current capacity to go ahead and take care of your issue. So who pays the price? It's the guy out in the shop. Now, all of a sudden, he welds, and what's he going to do? I got to pull out my grinder, and I got to grind off all this spatter. And it's just like, it's supposed to be a brand new machine. Yeah, it's a brand new machine. Well, we can eliminate this by pulsing. Come on, people. We're still doing all the same stuff. We're getting the exact same results. And trust me, if you're going to buy something, know what you want to buy, and you spec it out. Don't let somebody else spec it out, and don't let somebody shortchange you as far as, well, I can give you number 1 cable. It's just like, hey, it's 50-foot cables. Yeah, it's 50 foot. It's just undersized. Mm-hmm. Hey, it's a ground clamp. Yeah, it's a steel ground clamp. It's not worth a damn. Get something that works for you. Get something that's gonna work. And then guess what? Now, if I dial in 28.5 volts, I still will have a voltage drop. I'll still drop a volt and a half. But now I'm in the real world. And where do I measure arc voltage? It's kind of funny. It says arc voltage. I'd have to be measuring it at the arc, I'm not talking about open circuit voltage. I'm not talking about load voltage. I'm talking about arc voltage. Come and get some. And we need to start measuring in the right places, our CWIs and our CWSs and basically shops. If you want to get rid of spatter, if you wrote a good welding procedure, it'll work. Go to the place to make sure that it is working. Get your arc voltage measured. They're like little hidden things, but believe it or not, this is what's causing most of the issues that we have in welding, and it's beating us up, and we're beating up the people that are out there coming to work wanting to do a good job. Let's help them get the job done right.
Yeah, that's the biggest thing, because I'd put out videos, and we gave out all of our voltage, wire feed, speed settings, especially when we get into shielded metal arc welding, I'm giving out amperage settings and stuff, and people are like, oh man, you're running way too cold. I run like 160. If I was doing that out in the field, I'd be running 160 amps. This is, yeah, but you're probably running off an engine drive. You got 200 foot of lead strung out. I'm right here at the machine. I got 7 foot of freaking lead, dude. I've got no amperage drop in here, no voltage drop whatsoever. your cords are probably all beat to shit. So you're not, I mean, you've got 160 set out at your machine, but you're probably only hitting 110, 115 right there at the arc. And a lot of people don't see that or understand, that every time I connect a set of, a 50-foot extension of leads, now I've got 2 more spots for drop. I've got 2 more spots that I'm building up resistance because of my DINS connectors. Or, like you said, the forklift ran over it, the cable's all flattened out. It's, I've got resistance built up there as well. So, I mean, and that's the biggest thing about like when I get with my students and I'm like, hey, go through your machine every single day. Well, why? Well, because we had night class in here, and I'm not blaming anything on night class, but it's like, you have no idea what happened between the time you left yesterday and the time you got back in here today. Somebody could have dropped a block or something on top of the MIG gun, and now you've got because this happened to me when I was working with the ironworkers. I had was going in for a test with that Hobart XLR8 wire. Had no idea. We trying to set the machine up. Somebody had dropped a block or a heavy object right on top of the MIG gun, or on the cable of the MIG gun. So that liner on the inside was crushed, and I couldn't see it on the naked eye because it's like a self-healing cable. There was no indicators that there was damage there. It bounced, it crushed my my liner, and then it hopped right back off. So even though I had the wire feed speed dialed in correctly, now I've got like physical resistance because that liner's crushed. Yeah. So these are things we got to think about going through and start taking shit apart and looking at it, find out where the problems are actually lying.
Better that you brought up that stick application. And hey, look, that might be 2-aught cable that they're running all the way out there, except that 15-foot whip, that's number 4 cable. Mm-hmm. I might have a 250 amp or 300 amp stinger on there, but let me tell you something like that 15-foot of number 4 cable for a whip, because, well, hey, that's the part that I'm manipulating. I don't like messing with that 2-aught cable. Hey, I get it, but believe it or not, that's where you're losing that voltage. That's where you lose that stuff. Another thing that I'm going to ask you a quick question here. What a gas-to-wire ratio is? It's just like basically all the gas you use compared to all the wire you're using and all that kind of happy stuff, right? I mean, it's just like, so if I were to tell you that an average company would use, let's just say 15 cubic foot of gas for every pound of wire that they purchased. Is that good or bad?
15 per every pound? I would say that's bad.
That's bad? What do you think it ought to be?
Shit, I got no clue. Because I had asked you that at one point, like how much cubic feet, and you and Bill like worked it out with your calculators in like 10 seconds. How much cubic feet of gas is in a bottle, and how many spools of wire should you be able to run through that at like 45 CFH? And I can't remember. I think you gave me the calculation. I've got it somewhere. I got to pull it back out because I want to go over that with my students eventually when I understand it enough to talk about it. All right.
Well, let me help you with this real quick here. All right. How much gas should you use? All right. And some of this is theoretical, but let's get right to it. Let's say I've got a wire feed speed of about 365. It's an 045 wire, solid wire. All right. Running about 365, 370 inches a minute. Approximately, I'm pulling about 10 pounds of wire off that spool an hour. If I just hold the trigger, at that wire feed speed, it's going to be about 10 pounds an hour. Let's say that my gas flow is 40 cubic foot an hour. All right. So I've got 40 cubic foot of gas per hour, and I'm melting off 10 pounds of wire per hour. That's not a deposition rate. That's what's coming off the spool. All right. Mm-hmm. That's just wire feed speed. I'm saying gas to wire. All right. This is a math problem. All your gas divided by all your wire. So all my gas is 40. I got 40 cubic foot, right? And I got 10 pounds of wire. So, I mean, if my melt off rate is 10 pounds an hour, all right. So 40 divided by 10 is what?
4.
All right. So for every pound of wire, I'd only be using about 4 cubic foot of gas.
Right.
All right. But an average company will buy 15 cubic foot of gas. What do you think is going on here? Seriously. And hey, look, let's say it's 5 pounds. Let's say your melt off rate's 5 pounds an hour, 40 cubic foot an hour. What should it be? It's 1 to 8, right? I mean, it's like, so I ought to be using about 8 cubic foot of gas. I'm still using more than twice as much gas. got a little bit of an issue here. I mean, this is simple math, man. I mean, all of this stuff that I'm talking about right now, it's really simple math. But what it does is it leads us down a path. So what does this mean? And here's this guy. I mean, I'm the guy that sells gas, right? Largest gas supplier in the world. And I'm telling you that most people, in fact, I can prove to you, almost everyone buys 2 to 3 times more gas than they need. Simple. I've done it over 2,500 times where I've done this kind of ratio for people. Everybody's off. There are very few people that are close to where they ought to be. There are a couple of things that are going on here. Gas quality is absolutely critical. And if you have really good gas and it's delivered at the point of use correctly, guess what? That's going to be a wonderful thing for you. You know, you need consistency and blend. You need all this kind of happy stuff. But now I'm going to say, all right, well, if I'm in a bulk system or if I'm in another system and I'm buying twice as much gas, where's that gas going? Well, you know, everybody's saying, well, you got all these surges. Yeah, okay. And you know, it's just like I can put a spreadsheet together that shows you that you surge more gas than you buy. I can do that. That's not where all your gas is going. A little bit of surge is actually good. You want a little tiny burst, gives you a good arc initiation. All right, so you know, we can cut down a little bit there. Where else could I probably cut down? Well, there's overflow. You know, I'm supposed to be running 35, 40 cubic foot an hour. And you see everybody. I mean, it's like if that little ball on that flow meter isn't hitting the top of that, you know, that gauge like that.
You're not doing it right.
All right. Well, okay. Well, we might be getting some with overflow. So that might be another 15 to 20 cubic foot an hour. But that's not twice as much gas now, is it? So where's that other gas going? Well, it's usually leaks. Be leaking a hose, be leaking fittings, or be a pipeline leak and all that sort of thing. And what happens with those leaks? What's going on there? And you know, I hate to interject, you know, some physics and all that kind of stuff, but if you look at Bernoulli's principle and all that sort of thing, and we apply this, you start realizing, okay, let's say I'm on a piping system and I got 10 people, they all pull the trigger at the same time. Well, the system, you know, let's just say has about a 50 PSI, you know, I mean, it's like there's about 50 PSI inside the pipeline. Everybody pulls the trigger. And now all of a sudden that pipeline pressure goes below 14.7 PSI. What 14.7 PSI?
What is it?
It's atmospheric pressure.
Okay.
Right? That's our atmospheric pressure. So on a gauge, it's going to hit 0. As soon as that hits 0, something weird happens. Now, all of a sudden, instead of having gas blowing out of where it was leaking, right? Now, all of a sudden, we just created something. It's called a Venturi effect. We created a vacuum cleaner. That's basically what that is. So instead of all of a sudden the gas going, now it goes, it sucks in some air. Where's that air going to go?
Right in your whirlpool.
Yeah. I mean, there's going to be who's the lottery winner today? So all of a sudden somebody backs off of it, and now pipeline pressure goes over 14.7. So it's going to start showing some pressure in the pipeline. I've got positive pressure. It's going to push out instead of suck in. Well, that air is not going to get blown out, and it's not going to mix with your shielding gas. It's going to travel down that pipeline, and Eddie's going to pull it, and Dane's going to pull it, and then Paulie's going to pull it, and then Bubba pulls it. And guess what? That's where the air is, and Bubba goes on ahead and runs 12, 14 inches of porosity. His boss comes up to him, rips him a new one, and says, "What the heck is your problem?" "I don't know, boss." Like that. I didn't do anything different. "You can't weld. You're not any good at this stuff like that. I'm going to fire you if you don't get this stuff together like that. Gouge that stuff out and re-weld it." And Bubba's there looking at it like, I got no clue how this happened. And nobody's telling him. But what I'm describing to you right now is fundamentally the welding ghost. And this happens to every one of us. Anybody that's been in welding, this happens to us. And you gotta realize, okay, so what's going on? So let me get back to that gas to wire ratio. Why is it important to know what your gas to wire ratio is? Because quite frankly, when is good enough? Good is good enough that when everybody pulls that trigger, you know, it's like I'm getting gas. And quite frankly, if everybody pulls that trigger and that pipeline pressure goes below 0, that means that my header or my pipeline is not sized correctly. Hence, everybody is going to starve and everybody's going to have an issue. We've got things that are happening within our systems that people aren't paying attention to. And this is very simple math. This is all the gas that I bought. This is all the wire I bought, like that. I divide all the gas by all the wire. It's going to give me a number. Whatever that number is, now I need to look at my welding procedures, and I can pretty well determine, okay, this is what my melt-off rate ought to be. Short circuit, it might be 3 or 4 pounds an hour. Spray's got to be, 7, 8, 12 pounds an hour. It's got to be that. Well, that, divided by your, taking your gas flow and dividing that melt-off rate by it, guess what happens? You know what it ought to be. You know what it is. Go fix it. You can start eliminating discontinuities. You can start eliminating basically rejects because your system is broken and you can fix it. I mean, this is simple math again. These are things that you should know, that you want to know. Is anybody doing that? How many people do you know are doing that? And I can tell you that answer also. Not a bunch. And we need to look after our own systems. If the system is broken, welding will have a problem. Everybody in the shop will have a problem. And the whole idea is to eliminate cost, maintain, and basically have sustainable cost savings, but better than that, have a higher quality product. If I don't have to touch it twice, I'm in pretty good shape. Mm-hmm. Again, where does spatter come from? Just told you a couple places. Could be electrical resistance, could be a faulty gas system. Could also be the fact that you're using rubber hose. You realize rubber hose, if it's laying on the floor, will suck in moisture?
Will it really?
Oh yeah. Rubber hose is horrible. I can have an argon gas that's coming out, pure argon gas coming out of a cylinder with, let's just say, under 10 parts per million moisture. And if I put it through a rubber hose, and that rubber hose, let's say, is 15, 20 foot long, it's laying on the floor, and it's, let's just say, high humidity, coming out of that hose, it'll probably be anywhere from 100 to 120 parts per million moisture. You want to know why welds go bad and people say the gas is bad? Well, yeah, moisture is the root of all evil. Where's it coming from? You really, it's stuff like Cordan. I mean, it's like if you use a Cordan hose and all that sort of thing. Hey, look, if I've got about, let's say under 10 parts per million moisture coming out of the cylinder, and I'm using a Cordan hose, I might have 15 parts per million at the arc. I'm going to have a really nice weld. Because code will allow us 40 parts per million, right? I mean, that's what code, A532, that's what will allow us, is up to 40 parts per million moisture. The crazy part is that you can't get there from here. And it's not that my gas is better than their gas or their gas is better than it. No, it has to do with the delivery system. Most people are using the wrong kind of hose. And again, why? Cordan costs a lot more than rubber hose. So you buy a rubber hose because that stuff is cheap. Mm-hmm. Sure is. And at the end of the day, what are we doing? We're grinding this stuff out because now I got porosity. Because what's moisture going to, well, there's hydrogen in there. What's that going to do? And now I might get some, cracking at the toes and all those little things, that we all love to have to play with. Where's it coming from? It's coming from the system. We're not paying attention to it. And we need to start paying attention to our welding systems. We need to stop beating up the people that are out there trying to make us money. And we need to go on ahead and fix things. If we pay attention, we can actually have very efficient shops and we can get productivity up without spending any money. You don't have to spend money to fix this. You just got to make sure that everything's right. And it needs to be right at the arc. That's my gig, and I'm sticking to it. There.
And I think that's the problem that everybody sees, because, we talked about, like, your workpiece clamp, and now, we're talking about the gas line and the diameter size cable. Everybody wants to spend the least amount of money to get the highest productivity or the highest quality. And you got to make that initial investment up front, because you're going to get a big return on your investment when you do things correctly. But if you try to half-ass and cut corners, it's going to show up in the work. It's going to show up in your process.
You see, that's exactly it. And that's what I was getting to earlier. It's just like, look, if you're going to spec something out, spec it out correctly. If you really want to sit down with a welding engineer, somebody or a really good technician will tell you what, this is really what you have to have. And yeah, it costs more. Yeah, and you want to put it out for bid, but make sure that everybody's quoting the same thing.
Yeah, you got to make sure you're getting apples to apples.
Not a substitute. This is what you have to have, because now what you're talking about is your productivity and your cost structure. We need to deal with that, and we need to deal with it in an appropriate way. And yeah, we're going to stop beating people up.
Yeah, and I mean, and that's the sad part, is that at the end of the day, it falls on the welder. It doesn't fall on the guy that spec'd out the equipment, or that sold the equipment, or the guy that bought the equipment, and he got a really good price because whatever the case may be, but he bought like the cheapest shit he could get, and now you're trying to use that in a high production environment.
I venture to say, here you go. I'm gonna give everybody a brand new bottle of Coca-Cola, and it's gonna be ice cold, man. It's gonna be awesome. And you're gonna have to drink it through a straw. But here's the gig like that. There's a couple people, I'm gonna give them a brand new straw, and it's gonna be a plastic straw, and it's gonna be great. There's gonna be a couple other people, and I'm gonna give them a straw. But this straw, I'm going to kind of like, let's just say, run it through the commode before I give it to them, and they're going to drink that, all right? And then there's going to be somebody else that I'm going to go on ahead and I'm going to give them a straw, but I'm going to cut little holes in that straw all the way through it, all right? So that way, every time they suck on the straw, they don't get any Coca-Cola up there because, well, what happens? They're stuck in there, right? Mm-hmm. Your straw or that hose or that delivery system has everything to do with the quality of the product that you're going to get at the point of use. We need to deal with the point of use. What are our issues? What's causing those issues? And quite frankly, I call them hidden issues. They are, because you can't see them. But they're as obvious as the nose on my face or the nose on your face if you do some regular math, if you just basically pay attention to your welding system. You can become a lot more productive and a lot more profitable. And quite frankly, you're going to have people on the floor that are a lot happier. Why wouldn't you want to go down that path? Spend a little bit up front, a little bit more, get a lot more out of it.
Mm-hmm. So that's another thing I've looked into with shielding gas, and because working with students all the time, especially I got 10 booths running, I run into 10 new challenges per day, learning how to troubleshoot equipment. And and then another 10 that, that work in the evening class that I have no idea what's going on with their machines as well. But, you come in every day and there's always a new set of issues. And I love that part because it's a new challenge every single day. And I get to learn more about welding, and I get to learn more about what not to do. And so here's some of the things you want to look out for. So for instance, I bought one of the, it's just like a flow meter, but it's for the nozzle. What the hell's the name of that damn thing? You put it, you just check the gas.
Yeah.
To make sure that, so if I set my flow meter up at, 35 CFH, how do I know that's exactly what I'm getting at the end of my gun? How do I know that I don't have a clog somewhere, or I'm not sucking in air, or, I'm not leaking gas somewhere, to make sure that if it's set 35 at the bottle, that I'm getting 35 at the nozzle, because it doesn't matter what I have it set at the bottle. If I'm not getting that at my nozzle where I'm actually doing the welding, everything's going to go to shit. But the only method I have to verify that is just to make sure the flow meter's set right. And if that thing's not calibrated, if Bubba came in the night before and dropped it for you a couple times and you don't know about it, but that ball's still going to move, you're still going to be able to dial it in where you think. But if something's wrong in that system, you got to be able to verify that. So that's another thing that I picked up was just to be able to check my shielding gas at the nozzle. And I can use that for all my gas tungsten arc welding processes, as well as my gas metal arc welding, and then my flux core gas shielded. And it saves me, because there's times I went over to the flow meter and set it for 30, 35 CFH, and I was getting 20 at the bottle. Or I'm sorry, 20 at the nozzle. And I can show that. I can physically show that to my students and say, hey, look, something's wrong in the system. Let's start going back through and taking it apart and find out what's wrong with it. And there's times you have a bad flow meter.
You got a bad O-ring. You know what I'm saying? And I agree with you 100%. It's just like something's wrong. You got to go fix it, and you fix it, it gets better. But here's the crazy part. It's just like, all right, so I start getting into some higher speed welding, and semi-automatically, you're going to realize if it's not a wrist movement. I mean, if I've got let's say a weldment that I've got to make that's 24, 36 inches long and all that sort of thing, all of a sudden, it's like my actual weld travel speed. I mean, you top out around 15 inches. Some people can do 16 inches, but you're not going to do more than that all day long. I mean, after that, you have to really kind of like go to, let's say, some automation. But here's the kicker here. Now, getting to this thing, let's say that we're in that range, and it's just like, hey, look, it's just like, the weld's oxidizing and all that sort of thing. Well, I'm going to turn up my gas. No, don't turn up your gas flow. Get a bigger nozzle. I know that sounds crazy, but the gas flow, getting more gas flow is going to create turbulence. That turbulence is going to create a very unstable arc. You're going to create more problems than you want. It's not a higher gas flow. What you're looking for at this point in time is a broader gas flow. How do you get that? Get a larger diameter nozzle. If it's a 1/2 inch nozzle, go to a 5/8 or go to a 3/4 inch nozzle. You're going to get better coverage. You're going to start thinking about travel speed and how all these things come together. How do you pick a nozzle size? It has a lot to do with what you're doing and basically what your travel speeds are going to be. How much gas do you want to get out there and how much do you want to settle? Start thinking about, every gas has a weight to it. Argon, CO2, they're heavier than air. Where are they going to go? They're going to lay down on top of that weld. Unless, of course, you're going vertical up. Well, guess what happens? Well, then that gas is going to drop. The crazy part is if you're going vertical up, where's the molten puddle? It's below you, right? So that argon ought to kind of like reside a little bit there. But if it's, let's say, a gas metal arc and you're going vertical up, let's say you had a little bit of helium there, which is lighter than air, and all kind of stuff, where's that going to go? That's going to kind of like stay right up in front of your arc, and you're going to be able to manipulate your arc going up. Understanding where your gas is going is kind of like important. But again, you don't have to turn up your gas flow for the most part. Once you determine this is enough gas and this is working, I've ionized it. I'm getting the transfer that I'm looking for. It's consistent. I'm getting the weld bead and I'm getting the nugget that I've anticipated. If you're oxidizing too much, or the face of the weld is getting too oxidized, or you're not happy with the way that it looks, cool. Get a bigger nozzle. Just go to a larger diameter nozzle. Either that or get a trailing gas. But don't crank this thing up. Don't create instability in your arc. And again, it has to do with, more is better. And everybody says that, bigger weld is better. No, that basically means that I'm going to have more distortion. Mm-hmm. I'm going to waste more time. It's going to take me more time to put it down. It's going to cost more money to make the weld. No, just do it right the first time. And if you do it right the first time, every time, you can control your costs. But to do that, you got to make sure that your system is correct. And where we as an industry are not paying attention to that. And so we point at the symptoms like they're the problem. There's weld spatter. Well, that's a problem. No, it's a symptom. I'm going through a lot of contact tips. That's a symptom. I've got a lot of porosity. That's a symptom. People want to say that that's the problem. No, well, let's go find out what's causing it. And if you determine what's causing it, if you follow this back, and truthfully, there's a lot of things, there's some very specific things that cause each one of these. If you fix it, all of a sudden you start seeing all these other things coming into play. So your point about where's the gas important? Yes, those handheld flow meters are absolutely critical. And I think every lead man ought to have one, because if somebody's having issues, what's the gas at the nozzle? And if it's not right, let's figure this out. Maybe the O-rings are blown off the back end of the gun. You only know what you know. And quite frankly, if you're always measuring what you need to measure, at the point of use, guess what happens? You get what you need to get. It's kind of simple.
That makes a lot of sense, because anytime somebody troubleshoots, like I always teach, we start at the back of the machine and work your way all the way up to the gun. So regardless of what problem you're having, this is the way I teach it in class, regardless of what problem you're having, we're going to start right where I plug it into the wall, because that machine will still fire up. It'll still turn on. But if I don't have the appropriate amount of amperage or voltage coming out of that wall, the machine's not going to run effectively. It's going to turn on. And if it doesn't throw an error code, I don't know that my input power is bad. So we start right there. And then we come up, we follow all the power all the way through. And then we go back to the gas bottle and we follow it all the way back. And when I talk about the gas bottle, read the frickin' label. Don't rely on the color of that bottle. You know, oh man, I've had so many times I've walked in and students are trying to run like C25 when they're doing gas tungsten arc welding. It's like, well, the bottle's the right color. Oh, what's it say on the label? All the bottles are the right color. The company's going to paint them, you know, according to their logo and their color scheme. What does the label say? You know, thank God they can't hook up, you know, any of this shit to acetylene. Otherwise, we'd be in real trouble. You know, thank God they put left-handed threads on there. That's all I'm saying.
Do not give people any ideas.
Yeah.
You know, it's just.
But I mean, just going back through and diagnosing the machine. But I mean, like, most of your problems are going to be right there at the gun. Like you were saying, I've never even thought about a bad set of O-rings inside the gooseneck. I mean, I have with gas metal arc welding for aluminum because, you know, I got to pull those barrels off all the time and I can inspect the O-rings right there. But if it's internal inside that gun, I can't see that without taking the whole thing apart. And how many times are people doing that? Almost never.
Yeah, and, you know, it's like you pull the gun out of, like, you know, basically out of the, you know, the drive housing. There's 2 O-rings back there, typically. You know, you're going to have O-rings in different places. Hey, if the O-rings are gone or they're broken or they're sheared, guess what? You're sucking air. Mm-hmm. And yeah, that's a problem. You're either losing gas or you're sucking air or you're doing both like that. Quite frankly, neither one of those are very good. But again, it's just, what are we talking about right here? We're talking about your weld inputs. That's how important all these inputs are, because if your inputs are not correct, you cannot anticipate or expect your outputs to be correct. It's almost virtually impossible to have good outputs if your inputs are not correct. Well, I need to know that everything that's supposed to be happening at the arc is happening at the arc. I got to have the right voltage. I got to have the right wire free speed. I've got to have the right gas. I've got to have the right gas flow. I've got to have the right nozzle. I've got to have the right, basically, I mean, it's just like I need a leading or lagging axis, basically direction with my torch. I need to know if my traverse angle is correct. I need to know if that contact tip to work distance is correct. I need to know that the contact tip is tight. You can just keep on going and going, but, you know, it's just that the first thing that you're teaching your students is, you know, when you show up in the morning, check all of your equipment. That's the best thing you can do. You will eliminate most of your problems if you just do that. But what you can't do is determine that my weld cable is too small. You know, or, you know, it's just like, but if you see that the cable is frayed and where it goes into a lug, you know, a bunch of copper strands are all hanging out there and it looks burnt, get maintenance to fix that. Mm-hmm. You're losing voltage and it's invisible and you're going to struggle all day long. That's the key, like that. And do we need to teach our people on the floor this? Yes, but you know, as a company, we need to make sure that our equipment and our inputs to our equipment are correct. And as long as we're maintaining it correctly, the likelihood of having quality outputs is significantly higher. And that's just step one. Mm-hmm. And we can talk about quality standards some other day and how you really do, you know, how you come to them and how you can build really good quality standards and you know, and really address what you're doing and get it right first time, every time. But the first thing that everyone really needs to start paying attention to is, what are your efficiencies and what are your welding inputs? Are they all correct? And if they're not, why aren't they?
That's, I go back to the old adage all the time. You can't make chicken soup from chicken shit. I mean, you got to have quality in is quality out.
Absolutely. You know, so it's not a mind-boggling thing, man, but let's look at industry and let's look at what's going on. And everybody's in a hurry to get things out the door. Nobody's paying attention to what those inputs are. And we've got people that are buying equipment, and their job, and, you know, when they're buying product, their job is to make sure that they don't spend more money than they need to spend. But they really do need to make sure that they're buying what they think they're buying. And it does come down to, you know, it's just like getting our people, getting people that are seasoned, getting good engineers, getting good welding technicians, you know, and determining this is what's required. You really need to know. I mean, it's just like, what size cable should I be using? And that is such a critical function. What type hose and what size hose should I be using? It blows me away that there are so many people that don't buy the right hose. And it's, well, it costs too much. Does it? I guess that's up to them to tell me.
Yeah. How much is like not buying the right hose actually costing you in the long run? Like nobody ever points that out to them.
No, you look at efficiencies, even on cutting systems or anything like that. It all has to do with what your inputs are and how it affects your outputs. Everything has a ratio that's built to it. Everything does. It's just like, hey, look, this is how long a liner should last. This is how long an electrode on a plasma machine should last. This is how long the nozzle should last. This is how long the shield should last. I mean, it's like all these, everything, believe it or not, there are ratios that we've managed in. Of course, maybe I've just been in a room alone too long like that. You can build ratios around everything. The crazy part is that when you get 2,000, 3,000, 4,000, 5,000 points, you start realizing that this is pretty stable, and this is what life looks like. And you see some people that are getting a lot more than other people, and you start realizing that bell curve is real. And it's just like, all right, so let's start looking at what the ratios should be. And if you operate that way and you start realizing this is how long something should last in the real world, not theoretically, but in the real world, and this is how long it's lasting for us, what's causing it? I mean, it's not that difficult, but you got to get to those points.
Mm-hmm. That's like I always go back to like with drive rolls. That's probably one of the biggest things I see all the time is, okay, you're running a semi-automatic process. You're running some 035 wire. Let's use flux core, for example. You're running 045 flux core, but you were too lazy or you overlooked or you didn't have the right drive rolls. So you're like, oh, I'll just run some of these 035 V grooves. It works good for my copper wire. I should run this flux core just fine. And then you start deforming your wire, and now you've got your drive rolls are in there slipping, so you're not getting your true, wire feed speed that you have set at the machine, and it's happening right there at the drive roll.
Yeah. So what's the common fix there? Well, let's crank up that tension. So what happens to the wire? I mean,
I'm creating more deformation.
Well, yeah, and it's just like now you start looking at, okay, so what's the tolerance on the contact tip? What is it, 2000s, and all that sort of thing. Well, okay, now I've ovaled the wire out, so I've just eaten up all that tolerance. Well, what do you think is going to happen? You start pinning tips. So what do? Now I start hand tightening the tips, which creates even more problems because now I don't even have enough voltage to light this thing. You feed the beast. I mean, you just continually feed the beast, and it's just like, well, I need more gas. Well, I need more. And no, you don't. You don't need more. What you need to do is find out why isn't it working the way that it should be working.
You're treating the symptoms, not the cause.
There's a ratio to everything.
Yeah. Yeah. No, it's very good. And like one of the things that blew my mind is years ago, my buddy Ryan Eubank told me about the 12-foot rule. And it's because you got a 12-foot MIG gun. Now you can have a 10-foot rule, 12-foot rule, 15, however long your MIG gun is. But when you get that wire deformation right there at the drive rolls, and it causes that oval or that football-shaped piece of wire or a flat spot in there, you get a good 6-7 inches of weld, and then all of a sudden the contact tip burns back. You're like, shit. So you replace the contact tip, put it back in there. Meanwhile, when that part of that flat part of the wire came up to the contact tip and burnt back in there, and you give it a couple more test squeezes, you're wearing another flat spot in the wire. So once you clear your jam, put the new contact tip back in there, hand tighten it or hit it with the Welpers, you spray another 6 to 7 inches of wire in there, and boom, it clogs up again. Now you create another flat spot back there. So you got to fix that. You got to take your contact tip off, run out 12 foot of wire, and find out, or reel it back in onto the spool and find out, do I have a flat spot in my wire? Okay, what's causing that flat spot? Okay, my drive rolls are too tight. Because more is better, right? So we just crank it on down. If number 4 on that tensioner works good for or solid wire, number 7 is going to do even better. I'm not going to get any more feeding problems because it's going to force that wire out. And if you don't get a bird's nest, you wear that flat spot in there, and it's just a never-ending cycle.
Yeah, it's people, and this is one of the issues. Again, it's just like you cause problems. You have a problem, so you fix it, but the fix that you're putting in there is not the root cause. You really check your inputs. Mm-hmm. And if you're checking your inputs, your outputs are more likely to be accurate. I mean, it's just, you're going to get what you give. And quite frankly, that's the issue. Like that, we've got to look at every piece of this thing. And like I said, I mean, there are parts of this that you just got to understand. And of course, it's just like the welder themselves, they don't get to pick shielding gas. They don't get to pick the wire diameter or the type of, they don't get to pick any of those things. This is what you're being handed. You're going to make this stuff work. They didn't write up the welding procedures. Somebody else wrote up the welding procedures. So they're being dealt a hand, and now they have a piece of equipment that may or may not be able to handle everything that somebody gave them.
Mm-hmm.
It's not that they can't handle 045 wire, but if it's 035 drive rolls, or let's say there are 1/16 drive rolls on 035 wire, it's going to be a long day.
Yeah.
It's going to be a real long day, Look at your inputs, and that's step one. And then everything else after that, I mean, it's like, at some point in time, maybe we'll get into quality standards. It's just like, why do you pick a specific gas? Or why are you picking a diameter wire? And there's a lot of misconceptions as to why you do one thing over another, and we'll get into arc density. We'll get into, basically, what does shielding gas actually do? And truthfully, those are good conversations. I know they're lengthy, but they're good conversations. And these are things that people ought to know.
I'd definitely love to have you back on the podcast and talk about that at another point. I think that'd make for another great, interesting episode. So like for people that are like your average everyday welder that don't have access or don't even know what questions to ask or what resources that are available to them. Like if I'm a new welder, or let's say I've been, in welding for 3 to 5 years or better, and I want to get some additional information and different, some more knowledge about, kind of what we've talked about today. Are there any good books or other resources or videos or classes or anything you could recommend for somebody out there that's got that hunger for knowledge? They just don't know what questions to ask yet?
Truthfully, there are, and all that kind of stuff. And again, it comes down to, even if you don't know the questions to ask, it is time to start digging into, okay, how much more can I know? I happen to love the CWS program because, quite frankly, if nothing else, it'll wake you up. And it does give you some of the basic math that you need. And it's a great place to start. And anybody that's in a welding shop, and regardless if you're, 1 year or 3 years into this, it's a great place to start. It's an orange book. Buy it from AWS and truthfully go through it. There are tests at the end of every chapter. Take the test. If you get the question wrong, if you get the answer wrong, they have the answer, code right behind all the questions, and it tells you where to find the correct answer. Run through the book 2 or 3 times, and what you're going to realize is that you're just going to build your knowledge base. It's going to help you with different processes. It's going to tell you what works, what doesn't work, and it's a really good basis for it. As you start moving forward, it's just like, hey, look, there are technical colleges that you can go to, junior colleges that can give you a lot of good information, and you don't necessarily have to get a degree like that. I mean, there's certificate programs, and there are a lot of good educators out there. There's a lot of good programs across the country that you can dip into, and truthfully, find the school that has a good instructor. Don't find the school that just has a welding lab. Find the instructor. And you'll know if you're in a welding shop and you're seeing people that come from that specific school, and that's a pretty good hand that's coming out of there, they've got a good instructor. It's I'd say it's almost like dating. Pick out your welding instructor like you'd pick out your girlfriend or your boyfriend or your significant other. Make sure that that's the right person. Make sure that they know what they're talking about. And quite frankly, go find that welding instructor and take some classes. Now, obviously, if you're in a company and all that sort of thing, there are companies, and not just mine, that offer classes that will help you. There are OEMs that have classes that may be directed upon their specific product lines. And all of these classes are really, really, really good. I know for us, we offer up multiple classes. I mean, it's like we teach people how to do efficiencies, how to do all the math behind it. And truthfully, how you can sit at a desk and determine what's going on so you can go out and find it. We teach people, and we do classes that are half welding and half basically presentation on how to build quality standards and how to have the right quality standards for the product line that you're building. You know, it's just like there's a lot of different classes that are available. AWS is a great resource. The people you buy your product from are great resources, and OEMs are great resources. So it's reach out. You're going to find out. Everyone's got literature. Everyone's got something that they'll offer up to you. Read it, and you're going to get another piece to your jigsaw puzzle, and you start building it out. And pretty soon, you got a pretty nice picture going on.
Great, Rob. I mean, it's awesome. I appreciate you taking the time out of your day to come over and record the episode with us. I learned a lot on this episode, and I'm sure the listeners will too. And I just want to say thank you, and that I appreciate your time. And I can't wait to see you again in person. This whole COVID thing sucks. I'm hoping that if you get up to Fab Tech, we'll run into each other. If not, at some point we'll have to go out and grab a beer because I don't know. I love talking to you, man.
I'm definitely going to be at Fab Tech. I'm speaking at Fab Tech this year and basically it has a lot to do with how to hire and keep people. And keep quality people. And believe it or not, a lot of what we just discussed, it's a big part of it. So, yeah, I am looking forward to seeing you. And quite frankly, I'll get down to Florida. And I think what we need to do is really teach a class about shielding gases, even if it's a 4-hour class or a 3-hour class. We're going to get people understanding this is what gas will do for you. And it's not being taught anywhere. And, I'll come on down. We'll have some fun. And drink that beer.
All right. Yeah, let me know if you're in the area.
All right, man. Sure will.
All right, bud. And that is it for this week's episode. Thank you so much for listening. Be sure to swing by ArcJunkies.com and click on the merch tab for all the Arc Junkies hats and t-shirts. Be sure to tune in tomorrow for an all-new episode of Weld Wednesday with AWS, where I sit down and chat with Daryl Gashler, and we discuss the many benefits of joining an AWS section. Stay safe out there, and until next time, make every weld better than your last.